So let's start with the course objectives. So in phase one of the course, I'll introduce you to big data. I'll introduce you to Hadoop, explain how Hadoop works, get friendly with HDFS and MapReduce, get aware about the Hadoop ecosystem, and understand how Hadoop is used in real world. So let's talk about what exactly is big data. Big data is the amount of data that is beyond the storage and processing capabilities of a single physical machine. So in the most layman terms, big data is the amount of data where one machine gives up. So if you have all the resources with you, still there is a limitation on how much hardware can you stuff on a single physical machine. So what big data talks about is amount of data that is really massive and one machine cannot handle it. So the first dimension of big data is extra large volume. So data that has extra large volume comes from variety of sources, variety of formats, and comes with a great velocity. So first dimension of big data is volume, second is variety, and third is velocity. So typically when you talk about a big data implementation, you are referring to that the amount of data that is newly getting generated is really fast. So looking at big data, these are the three most important dimensions or characteristics. First is volume. For data to be referred as big data, generally the volume of the data has to be massive. Second is variety. For data to be referred as big data, generally the data would be semi-structured and may originate from variety of sources in variety of formats. And third is velocity. For data to be referred as big data, the rate at which data comes into the system is really fast. Quickly visualizing it, you have volume, data coming into the system with great velocity, data coming from variety of sources, that's variety. So this is big data. In a nutshell, big data is a lot of data that's getting generated really fast and it's coming from all over the place in all the formats. Now, over the period of time, few of my brightest students have had some questions and I've basically compiled those questions to paint this complete picture of big data. Let's look at those questions. So the first question that typically arises in your mind is, all right, looks like big data is clear, but how does this data look like? Well, there is no defined set as to how big data looks like. It can be anything like an RFID system generated file, a weblog, user interaction log, transaction history. It can just be anything. What do we do with this data? Analyze it. Now the point is, why should I analyze this data? This data does not directly mean money to my company. Okay. So why should I basically invest in analyzing this data? Yeah. So the point is, so you're asking me to invest $500,000 in basically setting up new facility, introducing a new technology stack for analyzing data that is not really transactional. Why should I invest this money and analyze data that is not directly money to my company? Well, it's in this huge heap of data, the golden nuggets of vital information stay. Analyzing this data would give your business an edge over competition. Now let's look at Amazon. Now to a lot of us, Amazon is an e-commerce website. But if you really see, what they do is they analyze your browsing history to perfection. So you search for an Xbox game, Amazon would already have this recommendation engine and machine learning techniques behind, which will basically figure out that, okay, you are a gamer, and then all the recommendations are around gaming. You are a parent and you have a 1-year-old baby boy, you buy diapers for him, and Amazon suddenly figures out that, okay, you're a parent, and suddenly you see all the recommendations are around products that are related to parenting, most probably to the age where your kid is right now. Amazon tries its best to learn that also, and you see the whole recommendation engine turning around that, and that's how you end up purchasing a lot of stuff, and that's where companies make a lot of money. So the idea really is, if you analyze data that's lying around in your company that's not really maybe structured, not transactional, but overall it can be of massive value. You can very well predict what's going to be next. So can we have some use case of analyzing big data? Absolutely. Identifying customers who are most important. Identifying the best time to perform maintenance based on usage patterns. Analyzing your brand's reputation by analyzing social media posts. These are some use cases of big data. How can such huge data be analyzed? As the volume is beyond processing and storage ability of a single physical machine. Now one machine is clearly not enough. When one machine is clearly not enough, we need some distributed to do it. And so what we need is we need some distributed way. Then comes the biggest argument. Wait. Distributed systems like MPI and MPP have been around for more than a decade. So do we even need to see this presentation further? So you're teaching something that's 15 years old. Do we even need to see this presentation? And forget about that. Does the world really need another distributed system? Why did somebody take the pain to basically create another distributed system? Was it really required? Does the world really need another system? Well, the answer is yes. The world certainly needs another distributed system. Let's see why. So if you really see, you have your application server, you have your storage server. So what would happen is your data would be stored in storage area network here. So let's say you had 50 terabytes of data that would get stored in a centralized location like a SAN, and then you would have your app servers. So let's say you have your 50 terabytes data, you have your app server 1, app server 2, app server 3. These app servers are operating on data which is on SAN. Now what happens is if you have 50 terabyte of data, each server would pick up 1 terabyte of data, process it, write back, process it, write back, process it, write back. That's how it works. Now what happens is each guy gets his share of data, processes, writes back, and the world was working, or let's say your distributed world was really working. So what was happening is program was running on each app server, all data was on SAN. Before execution, each server gets the data from SAN, and after execution, each server writes the output to the SAN. Now this approach had certain problems. Problems with typical distributed system. First, there was huge dependency on network and there was huge bandwidth demands. Now look at it. You have 50 terabytes of data on SAN. You are reading 50 terabytes of data across the network. 50 terabytes of data across the network. Really bad idea. Scaling up and scaling down was not a smooth process. So with that setup, you can't simply scale up or scale down, because if you are my best programmer and you are writing code for 10 machines, can I just add another 1,000 machines and expect your code to work as it is? Not really. Partial failures were very, very difficult to handle. Okay. If there were 50 machines, what if machine number 32 went down? You as a developer will have to take care of that, and that was a painful part. A lot of processing power was spent on transporting data, and data synchronization was required during exchange. So these 5 issues were there, and that is why world needed a better distributed system. So the typical distributed system had these problems, and world was looking for a big distributed system, and that is where Hadoop comes into picture. Hadoop is nothing but a typical distributed system that will solve these 5 problems for you. Hadoop is no magic, it is a normal distributed system which will solve these 5 problems for you. Okay. So far we've seen problems with typical system, we've seen typical distributed system, we've seen what is big data, we've seen why big data deserves our attention. And this brings us to the end of what exactly is big data. Alright, so now let's talk about what exactly is Hadoop. Now, Apache Hadoop software library is a framework that allows for distributed processing of large sets of data across clusters using simple programming model. In more simplistic terms, Hadoop is a framework that facilitates functioning of several machines together to achieve the goal of analyzing large sets of data. Now, in the most layman terms, Hadoop is a magic where multiple machines are working together to do your job. That's it, nothing else. So Google created its own distributed computing framework and published papers about the same. So the first company that visualized that big data would be a problem was Mr. Google. So the first company that visualized big data would be a problem is Mr. Google. And they created a solution around that. Now they did not open source the solution, but what they did is they went ahead and they basically gave away 2 white papers. So they gave away 2 white papers for everyone to read and see how Google is solving the problem of big data. So Hadoop is basically an idea completely based on Google's white papers. Hadoop consists of 2 core components, HDFS and MapReduce, the Hadoop Distributed File System and MapReduce. A set of machines running HDFS and MapReduce is known as Hadoop cluster. Individual machines are known as nodes, and a cluster can have as many as one node to several thousand nodes. Okay, so you can basically have as many as one node to several thousand nodes. The easiest way to visualize Hadoop is this. These are set of machines working together. They take in your big data and they give you 2 services, processing and storage. They give you 2 services, processing and storage. Now, if you slightly dive deep, what you see is Hadoop is nothing but a master-slave configuration. It's a system with master and slave configuration. Now, on the master node, what you have is 2 components, storage and processing. And on the slave node also you have storage and processing. The guy who takes care of storage on master node is called as name node, and the guy who takes care of storage on this is called as data node. The guy who takes care of processing on the master node is called as job tracker, and the guy who takes care of processing on the slave node is called as task tracker. Okay, these are 4 most important daemons. So what happens is this. From your laptop, you would first give your program, and then you'll first give your data, and then you will give your program, and that would be passed to the cluster. So this is your Hadoop cluster, and it would take your data and program. So first what happens is you give your data. So right from your laptop, you would basically submit data, and the data would be given to the cluster. Now once you write your data is actually cut into pieces of 64 MB, and it is spread across the cluster. Okay, so what happens is, let's say you write a file which is 640 MB, it will be cut into 10 pieces of 64 MB each. 10 pieces of 64 MB each. Okay, and will be spread across the cluster. Okay, now while it is spread across the cluster, each block will be replicated 3 times. So if a file is 640 MB, it will be cut into 10 pieces of 64 MB each, and each block will be replicated 3 times. Each block will be replicated 3 times. So totally there will be 30 blocks. Okay, so that is how your data would be stored. After that, you would give your program, and your program would basically also be submitted to all the slaves. Okay, once your program is also submitted, your program then runs on local data of every slave and gives you the output. So this is how the Hadoop works. So let's talk about what exactly is HDFS. So HDFS is a file system that is different from Linux file system, but it is sitting on top of Linux file system. So I can answer your question in one line, but let's understand the whole thing, because that will help you basically collect the pieces, connect the dots basically. So HDFS is a file system that's different from Linux file system, but sitting on top of Linux file system. Now let's understand this carefully. Today morning we all go for shopping and we purchase 4 servers, or let's say we purchase 5 servers. So server 1, server 2, server 3, server 4, server 5. Each of the machine is Now, I want to store 5 terabyte of data. I mean to say, yes, with replication, I want to store 5 terabyte of data. Is it possible right now to do that on any of these machines? So the answer is no, I can't. What is HDFS actually? HDFS is a magic where each machine pledges some space. So each machine is going to pledge you 3 terabytes, which is reserved. So this machine says 3 terabyte reserved for Hadoop. 3 terabytes for Hadoop, 3 terabyte of Hadoop, and 3 terabytes of Hadoop. And you tell this master that, this is a master, take 3 TB from each guy and make it look like one massive hard disk. Now tell me, can you now store 5 TB on this setup? Can I store 5 terabytes now? I can store 5 terabytes. How? Simply putting it, this master is told that this is like one hard disk, 3 plus 3 plus 3 plus 3. Now we have 12 terabytes, you can store 5 terabytes. So what really happens is, when you write to Hadoop cluster, master kind of breaks the data in blocks and stores it across this 12 terabyte. When you access the data, master integrates all the blocks and shows you the file. So what's your gut feeling? What will with itself when it is handling 12 TB of storage? Master, we've told him that, hey master, I've given you 4 servers, you break everything in pieces and store it. Okay, so if I give you a file which is facebooklikes.txt, which is, let's say, 5 terabytes, you break it into blocks of 64 MB and spread it across the cluster and store it. So that's called as metadata. Okay, so what really happens is, this guy stores something called as metadata or mapping. Basically, Facebook likes.txt is blk 001, 002 to all over the place, correct? Okay, now from your laptop, when you want to insert the data, you will be contacting the name node. Put new file.txt. So yes, to answer your question in one line, you will have to connect to name node. Okay, when we go to more details, you will realize that there are some deviations from that, but for now, yes, in one line, you will talk to the name node and say, hey, I want to put a file.txt. Name node will say, okay, wait a minute. How big is the file? It is 300 MB. So yeah, we will make 5 blocks and spread across the cluster. All that is taken care by the name node. But there are few deviations which we will see at the end of the presentation. Okay. So when you say Hadoop, there are 2 components. By now you are clear. One is HDFS, another is MapReduce. So all the jobs in all the machines for entire data. The only thing is, same data will not be processed twice. This replication is there only for failover. So entire data will be processed once on some or the other machine. There is no point in processing 3 copies of the data, right? That is there for your failover. That's it. So what happens if somebody shoots someone in the head? What happens? So your main node going down is like somebody shooting you in the head. So everything will come to a standstill. There is a failover mechanism, right? But what I'm trying to right now say is, without the main node being up and running, your cluster is useless, completely useless. It cannot even move one step forward. There are failover mechanisms which we'll discuss, but your main node is the brain of the system. Without it, you're dead, right away dead. Okay. So if you don't have techniques to save that, you are in a vulnerable position. Okay. So HDFS, for Hadoop to be able to process the files will have to be in HDFS first. Okay. We understood that for me to process any data, the data has to be dumped inside HDFS. HDFS is responsible for storing data. Data is normally split into blocks of 64 or 128 MB and spread across the cluster. By default, each block is replicated 3 times and it's configurable. Now, logically, yes, to ensure data is not lost, similar blocks are always replicated on different machines. Why would you replicate same block on the same machine? Why would you take a backup of your laptop? So, HDFS basics. HDFS is a file system based on Google's GFS, operates on top of native Unix file system, provides replicated storage for data using cheap commodity hardware. HDFS file system is read-only. You can write only once, you can't update the data. You can delete the data in Hadoop, you can't update the data in Hadoop because it's a data processing platform, but yeah, you can't update the data. Performs best with small number of large files. It's the name node and the data node that takes care of HDFS, and for HDFS to be accessible, name node has to be up all the time. This is the diagram that when data goes in, it's broken into blocks and the metadata is stored here, which says data.log is block number 1, 2, 3, 4. So this is how HDFS works. Let's move to MapReduce. So now your data is in. Your data is broken into pieces, stored across. That takes care of it is called as MapReduce. So there'll be a separate session on MapReduce. You'll be getting a lot of details there. Let's understand the concept here. Here we will just understand the concept. Okay. So MapReduce is the data processing component of Hadoop. It attains the task of data processing by distributing tasks across the nodes. Task on each node processes data locally. Okay. The data is processed locally. So we've seen that. In between map and reduce, there is a phase called shuffle and sort. So there are 2 phases, map and reduce, and in between map and reduce is a phase called shuffle and sort. So let's understand this. Assume that we have a file that has some text named as data.txt, and the goal is to count number of times each word occurs. So let's say the text is, hi, how are you? Where have you been these days? Where can I find you? And are you there? And the anticipated output is this. My expected output is hi, 1, how, 1, r, 2, u, 4, where, 2, have, 1, been, 1, these, 1, days, 1, I, 1, find, 1, there, 1. I just want to count the words. So in MapReduce, what really happens is everything is key value pair. Everything is key value pair. So in this case, your line number is key by default and line is the value. So here you have 4 key value pairs. 1, hi, how are you? 2, where have you been these days? 3, where can I find you? And 4, are you there? These are the 4 key value pairs that you have. So hypothetically, this is how your map phase looks like. So you have, let's say, map 1, which will take, hi, how are you? Map 2 would take, where have you been these days? Map 3 would take, where can I find you? And map 4 will take, are you there? What happens is each map will give his own output. Each map will focus on his business and give you the output. So map 1 will give you hi, comma 1, how, comma 1, are, comma 1, you, comma 1. Map 2 will give you where, comma 1, have, comma 1, you, comma 1, been, comma 1, these, comma 1, days, comma 1. Map 3 would give you where, comma 1, can, comma 1, I, comma 1, find, comma 1, you, comma 1. And map 4 would give you are, comma 1, you, comma 1, there, comma 1. So individually, every guy has done his job. Now it's time to integrate all of this. So you get output from everywhere, and in shuffle and sort, what you do is you bring everything together and you sort it. So you say R is 1, comma 1. Bean is 1, can is 1, days is 1, find is 1, have is 1, like this. Where is 1, comma 1. So you have where and there. So it's 1, comma 1. And U is U, comma 1, comma 1, comma 1, comma 1. So that's how you get this. And then you give it to the reducer. In reducer, what you get is hi, comma 1, how, comma 1, r, comma 2, u, comma 4, where, comma 2, have, comma 1, been, comma 1, these, comma 1. You get your final aggregation, and that's your final output. So that is how map and reduce works. That is how map and reduce works. Let's quickly look at the real world exam or real world scenario of map and reduce so that it will be clear. Now, as a customer, I come to MapReduce and say, I have this job for you, in the sense the whole task for you, and I know you have 10 guys working for you. Can you get this done for me in 3 days? So what Mehul does is he says yes, because I'm his customer, so he'll say yes. What step 1 Mehul does is he looks at my job and gets all the prerequisites in place. Breaks the job into smaller pieces of tasks, allocates tasks to each developer, message to each developer is mind your own business and don't worry about whole output. Just do your thing and leave for the day. Step 5. Each developer completes his job and leaves for the day. Step 6. Now calls us team lead and says, take every developer's output and start working towards unlock. Lead takes output of each developer and now starts by sorting. You can call it as sorting or bucketing each output. Now if you take this scenario, okay, so I am the developer, Mehul is the job tracker. Okay, so when I give my task to Mehul, I'm just giving developer submitting job to job tracker. So what job tracker does is, job tracker breaks the tasks, breaks the job, allocate tasks to each developer. So that is start of map phase, where every guy is given his task. So this is map phase where every developer is doing his job. Every developer is focusing on his job. After every developer is done, that is your end of map phase. After that, Mehul asks team lead to collect output from every developer. The team lead will collect it. That is shuffle, where every developer is giving his output to the team lead and saying, my job is done, I'm leaving. Team lead is collecting the output, and basically, so we've done shuffle and now it does sorting. Okay, so it sorts everything, buckets everything, and finally integrates the whole thing. That is reducing to the output, basically coming to the output. The reducer completes the output. Reducer gets output and informs job tracker. So job tracker tells developer output is ready and is in the following directory. So is MapReduce clear? That is how MapReduce works. We've seen what is the big data. We've seen what is Hadoop. We've seen what is HDFS, the storage, and we've seen what is MapReduce.